So we're going to go over the properties of exponents. These are in your book. Most algebra books have them in like 3 different places because we keep needing them. So as we work with these rational exponents, we want to know those properties. Okay, so we've been over some of them, but I'll just give them to you again. If you have a base to a power times, and then you have another expression with the same base, but a different power, then you're going to add those exponents together. So if you had something like a to the 7th times a to the 9th, that would equal a to the 16th. You would add those exponents. So I'll give you the rule and try to give you a quick example. All right, the power property. So if you have a to the m, and then you're going to raise it to the nth power, that's going to equal a to the mn. You multiply those powers. So I always say power to a power, you multiply them. So if you have a to the 5th to the 3rd, that's going to equal a to the 15th. Okay? So you're going to multiply those. Power to a power, you multiply them. Okay. If you have 2 different bases, like a and b, and they're raised to some power in parentheses like that, then they each get that exponent. So a to the m, b to the m. So if I had something like 4x, and I was trying to square that, I would have to make it 4 squared and then x squared. And then that would simplify to be 16x squared. So sometimes when you have a number here in front, a coefficient, a numeric coefficient that's not 1, you have to, it throws students because you have to remember that that gets the exponent as well. Okay? All right. Quotient property. So if you have a to the m divided by a to the n, notice the bases are the same, then you can subtract those exponents. And it's going to be the numerator minus the denominator. Subtraction is not commutative, so we have to keep that in the right order. So let's say I had x to the 7th over x to the 3rd. I can subtract the exponents and have x to the 4th. Okay? All right. Oh, if I have a to the 0 power, that just equals 1. Okay? Now, sometimes that's confusing to students. They're like, why would that equal 1? All right. If you had a to the 7th over a to the 7th, well, that's just going to equal 1, right? Because you have the same thing in the numerator as you do in the denominator. That's kind of like Fractionville, you know, that's what it's going to equal. It's going to equal 1. But the rule of division says you can subtract those exponents. Well, what's 7 minus 7? That's a to the 0. And so that has to equal 1, or it's not a happy day for mathematicians because we have to have the rules be in alignment. Okay? All right. So that's why it's equal to 1. Sometimes we say anything to the power of 0 equals 1, which is true, but sometimes it's hard to know what's the base. Okay? But we'll work on it. Quotient to a power property. So let's say you have division, but the bases are different, and then you've got an exponent, you know, out here. Then they each get that exponent. So it's a to the m over b to the m. So for an example, let's say I have x to the 3rd over y to the 5th, and I want to raise that whole thing to the 4th power. Well, I get to practice a couple of my rules here then. It's going to be x to the 12th, because I'll multiply power to a power, and then it's going to be over y to the 20th, because I'm going to multiply the power on the y, 5 times 4. Okay, so that's how it would simplify. And then lastly, we have our negative exponent property, which we've already gone over that, but I'll do it again. So if you have a to the negative m, that is equal to 1 over a to the m power. So if you have a negative exponent, and you don't want it to be a negative exponent, you can change it. Okay? Those are our exponent rules.